Hey guys, this is for your classwork for Friday, December 4th, where we're solving systems of equations. And on this lesson, we're putting linear equations and exponential equations on the same graph. So let me pull that up and do some with you. All right, so here we're going to just plug in these values that I have for x. We're going to plug those values right here into both equations for x to see what our y values are. All right, so I'm going to start with, let's do red. We're going to do the first equation, which is an exponential equation. So if I plug in -1 right here for x, 2 to the -1, that negative exponent turns it to a fraction. So the fraction is going to be 1/2. If I do 2 to the 0 power, anything to the 0 power is 1. 2 to the first power, 2 to the first power is 2. 2 squared is 4. 2 to the third power is 8. And 2 to the 6th power is 64. All right, let's go ahead and graph this. So our first coordinate would be -1, 1/2. So left 1, up 1/2. The second is 0. Don't go right or left, but go up 1. The next one is 1, 2. Go right 1, up 2. Then we have 2, 4. Go right 2, up 4. Then we have 3, 8. And finally we have 6, and 64 is way up there, right? So let me see if I can do an okay job. And then this is going to go up a long way straight. All right, so obviously this doesn't look perfect, but the exponential graphs are always going to have this same look. Anyway, sorry about that. Let's pretend that looks fantastic, okay? All right, now let's do the second one. Let's go ahead. We'll do that one in black. All right, so if I plug in -1 right there, so 7/3 times -1, we're going to use our calculators. Hopefully you guys are going to use your calculators for all of these. So 7/3 times -1 is -7/3. And then -7/3 times, or excuse me, +1 is -4/3, which is -1.3. So, you know, if you have a fraction on your calculator, -4/3, to make it a decimal, you're going to hit that, the double arrows right there, right? And that's going to turn it into -1.3. All right, anything times 0 is 0, so 0 plus 1 is 1. 7/3 times 1 is 7/3, and 7/3 plus 1 is 1 and 7/3, which is, let's see, 3.3. 7/3 times 2 plus 1, 7/3 times 2 plus 1 is about 5.666, or we'll say 5.7. 7/3 times 3 is 7, and 7 plus 1 is 8. And then 7/3 times 2 would be 14, and 14 plus 1 is 16. All right, so let's graph the black coordinates. So -1, -1.3, left 1, down 1.3. 0, 1. 1 and then 3.3, be about right there. Right 2 up 5.7 up to right, 5.7, almost went way too high. And then we have 3, 8. And then we have 6, 16. And then we're going to pretend like I can make a straight line, which we all know I cannot do that. So this is really taking a lot of my concentration. Hey, that's not too bad. All right, so that means that since those two lines intersected here and here, that means that this system has two solutions. two solutions. And what are they? They're 0, 1, and they are 3, 8. So those are my two solutions. All right. All right, so at this point, I want you guys, just to save some time, I want you guys to go through the rest of the slides, use your calculator, go ahead and fill out those T-charts, and then I want you to come back and we can graph them together, or you can go ahead and graph yours, and then you can check your answers with mine. But pause the video, fill out your T-charts, and then come back, okay? All right, so hopefully all of your T-charts are filled out. So I'm not going to, I've already done mine as well. I just haven't written them here. But we'll graph them together and make sure we get the same answers. And if you guys disagree with me, please respectfully let me know that you disagree with me and we'll look at them. 1, 3, 5, 9, and 13. All right, how'd you guys do? All right, so we'll go ahead and graph the green one, the second equation. And of course, this is the linear equation because the variables are both raised to the 1 power. And our exponential has the variable that is the exponent. So those have the curve, and our linear equations, of course, are straight lines. All right, so let's do -1, -1. So left 1, down 1. I'm doing the second equation first. 0, 1, don't go right or left, go up 1. 1, 3, 2, 5, 4, 9, and 6, 13. So that should be a straight line if I'm capable of such a thing. All right, that's not too bad. And then let's turn over to the black one. So we have -1, and then up 3.5, 0, 4, 1, 5, 1, 5, 2, 7, 4, 19. So 4, 1, 19 would be about right there. So we have that little curve. So what do you think, guys? Will these lines ever intersect? No, they will not. So that means this solution has no, or this system of equation has no solution, no solutions. All right. Let's look at what you guys got for number 3. Number 3 on my y1. So my first equation, I got -1.5. 0 and -1, 1, 0, 2, 2, 14, and 62. All right, if you guys haven't done these yet, I want you to pause the video, go through them, and I want you to finish the T-charts. I want you to do that part on your own. All right, let's go ahead and do the second equation. So for -1, I got 6.5. For 0, I got 5. Then I got 3.5, 2, -1, and -4. All right, since I have the red on my pen, let's go ahead and graph that. So we're gonna go left 1, up 6.5, 0, 5, 1, 3.5, 2, 2, 4, -1, and 6, -4. So, oh, I would have missed that first dot. Maybe if you guys have a ruler, it'll be less stressful for you guys. All right, I'm going to turn on the black ink. So then we have left 1, down 1.5, 0, -1, 1, 0, 2, 2, 4, 14, and then we have that big exponential increase. All right, so something like that. Oh, I missed it. All right, so we see that our lines intersect. So that means there is one solution, And what is the solution? I can see it right there. The solution is 2, 2. One solution, and that solution is 2, 2. All right, let's look at number 4. You've already done your T-charts. So on our Y1, if I raise -2 to the -1, that's going to make a negative fraction, -1/2 or -0.5. Anything raised to the 0 power is 1, so -2 raised to the 0 power will be -1. And then we have -2, -4, -16, and then -64. And then we'll do the red. So our second equation, that's our linear one, right? We have -6, -4, -2, 0, 4, and 8. I'll do the red one first. So -1, -6, 0, -4, 1, -2, 2, 0, 4, 4, and 6, 8. Oh, that's not a 6, that's a 5. Just kidding. Right there. Let's get rid of this one. All right, so then we're going to connect those dots. We get a nice straight line. Oh, just north of it, right? Now the black one, let's do -1, -0.5. These are counted by 2's, right? So 0, -4, 1, yeah. What have I done? 1, -2. Did I do that one wrong? I did do it wrong, didn't I? Oh, I graphed, okay. I did the red one first. Okay, I'm so sorry. So 0, -1 would be, that is -1. Oh my goodness, I got myself all confused. All right, let's start over the second one. All right, let's start over for the black one. I'm looking at this one now, right? So I'm gonna go left 1 down half, and then 0, -1 will be about right there. And then 1, -2 is gonna be right there. And then 2, -4, 2, -4, and then 4, -16. All right, so basically I have this thing right here. So, sorry about that, I got myself all confused. So this does have one solution. And this solution is 1, -2. There it is right there, 1, -2. Both of those equations go through that point. All right. Messed that one up. Let's try number 5, see if I can do that one any better. Now the numbers are getting a lot bigger here. And really the best thing is to go ahead and fill out your T-chart first, which hopefully you've already done that because I asked you to, in order to see what you should number your graphs by. So you want to use most of the graph. You don't want most of your graph blank. And so that's why you always look at your T-chart first and then say, okay, well, what would be appropriate to number my X and Y axes? All right, so I have 45, 48, 51, 54, 55.5, put that for a specific reason, 57 and 60. And then I'll use a different color. Let's do red on this one. This is going to be 30. This is going to be 36, 43.2, 51.8, 56.8, 62, and 74.6. All right, so since I only go up to number 5, I skipped every other number. And I counted this way. Of course, this is 0. And then I know my biggest number goes up to 60. So I want to make sure I get 60 on my graph. So I figured out that if I count by 5s, that means 60 is going to be at the very top, which is good because I want to use the smallest numbers possible, but still use numbers that are small enough to fit all of my digits on the same graph. Because you always want to use the smallest number possible without leaving out any of your points, unless it goes off the page like our other ones did. All right, so so let's do the red first since I have my red ink on. So 0, 30 right here, 136, 2, 43, and 43.2, so that'd be almost just a little more than half, right? And then what is that number? 51.8. Doesn't look like a 51.8, but it's supposed to be 3. And then 51.8 for, I did 3.5. I did 3.5 and 55.5, so 3.5. Oh my goodness, it's probably even too high. And then 4 and 57, 57, and then 5 and 60. All right, and this is my exponential one. I don't think I did that right, did I? 51.8. 51.8, and then, oh, look, I skipped from here to here. Oh my goodness. I hope y'all pay more attention than I do. Oh, it goes up. See, I didn't use high enough numbers, but that's okay. All right, so I did 3.5 and a 56, and then 4 would be 62, and then 5 would be way up here, wouldn't it? All right, so anyway, that's pretty close, I guess. So we still have the little curve. If I do it right, we have a little bit of a curve. Anyway, it would continue to go up and increase exponentially. All right, so now we're doing the black one. So 0, 45, 1, 48, 2, 51, 3, 54, 3.5 would be 55.5. See, I was thinking I did the wrong number, but anyway, this one should be slightly under the red one. And then 4 and 57, and then 5 and 60. There we go. This is our linear one. But anyway, the reason I did 3.5 is because they were really close to touching around 3.5, but they don't exactly touch. But we know that at 3, this quantity is less than this one, right? But at 3.5, this quantity is a little bit more than this. So where do they cross? They cross somewhere between 3 and 3.5. So we could try 3.1, 3.2, 3.3, 3.4. But we would be really close. So there is one solution. And based on our graph, we know that they cross somewhere right here, which would probably be about 3.25, something like that. So the solution is between 3 and 3.5 and a y value. Okay, so that would be the x value and then the y value. We could, if we wanted to, we could probably figure out what it is if we, used our calculator. But anyway, we're really close. Between 3 and 3.5, that's pretty good, right? All right, and then number 6. So hopefully you guys did okay on those. All right, so number 6. Here's 40, 41, 42, 43, 44, 45, 46, 46.2, and 47 for our linear. And then for our exponential, we have 15, 18, 21.6, 25.9, 31.3, 37.3, 44.8, 46.5. It's really close right there, isn't it? And then 53.7. And then based on the numbers, I numbered by ones. And then for my y-axis, I numbered by fives up to 60 again. So this is 0, 0, 10, 15, 20, 25, 30, 35, 40. I'm going to really try this time not to get my numbers and my colors and my equations mixed up. So we'll see how I do. So I'm going to do the red first. So 0, 15, 1, 18, 2, 21.6, 25.9. It's really close to 30, isn't it? 4 is 31.5. Oh, that's way too high, isn't it? Whoops. All right. What was that? 3 and 25.9, which is really close to 25. 4 and 31.1. 5 and 37.3. 6 and 44.8. 44.8. Really close. 40. Let's see, 6.2 and 65 or 45. About right there. And then 7 and 53, something like that. All right, so this is our curved one because it's the exponential. And then let's do the black one. So we have 0, 40. 41, 42, 43, 44, 45, 40. 5 is 45, 46, 46.2, and then we have 47. So there's our linear one. All right, so where do they intersect? Not exactly at 6.2, but look how close those are. So yes, there's still one solution. And we could say it's about 6.2 and 46.225, something like that. 46.3. So that's approximate because that's not exact, but we're really close. We're really close to having the exact coordinate. All right, let's do number 7. And then you guys are going to do the last few on your own. Yep. All right, so let's see what we got here. So this is number 7. So for 20, for 0, I got 20. I got 123.8. 148.6, 178.3, 214, 234.4, 256.8, and 308.1. And then when x is 0 on the second one, y is 100. When x is 10, 10 times 10 is 100. 100 plus 100 is 200. And then these increase by 10. 220, 230, 235. Now, I'm not just doing these fast, guys. I've already done this. Like I did this over Thanksgiving break and I checked my answers and I saw where they intersected, and that's how I got these numbers to work out the way I wanted them to. So I didn't just do this quickly. So if you're like, how is she doing this so fast? I'm a little confused on what's going on. I mean, just realize that I've spent time on this. I didn't just, you figure out what the values are with your calculator, you come up with an appropriate graph, you come up with appropriate numbers over here. You want to see if they do intersect, where do they intersect? So don't be discouraged if you're struggling just a little bit. So based on my numbers, I came up with counting by 25s on my y-axis. 175, 200, 225, 250, 275, and 300. All right, so we're doing let's do the black first. So 0, 20. And then, okay, that's why I counted by 2s, because I jumped up here to 10. All right, so when x is 10, y is 123.8, and then 12, well, let's just skip 11. Let's go to 12, 178. 178 would be closer to 175. And then we have 13. Okay, that's probably why okay, anyway. All right, so 13 would be 214. 214, just over halfway. And then when x is 14, y is 256. 256, and then 15 and 308. All right, so here's our exponential. Ooh, that should not be that straight, but anyway, I made it too straight, but it's the pen and it's my unsteady hand. Oh, that's terrible. All right, and then let's do the red one, 0, 100. And then when 10 is, x is 10, we're jumping up here to 200. And then when x is 12, we have 220. And then 13 will be 214. Wait, what'd I do? 12 and 220. And then 13 would be 230. 230. Why are these so far off? 230. This one's too low, isn't it? That black one should be up here. The black one should be up here. This is not right. Anyway, I messed this up. But they intersect really close to when x is 13. I didn't draw it right anyway. So my straight line would, even though it's supposed to be in red, it's supposed to go up like this. So this is close to the intersection, you guys. So anyway, hopefully you can see it's one solution, even though my graph is a disaster. And it would be really close to when x is about 13 and a half, because look how close these numbers are. All right, these are bigger, bigger, bigger than these until you get here, until you get when x is 14, and then this is now the biggest number. This side is bigger until you get to 14, x is 14. All right, anyway, so now you guys are supposed to do the last 6 on your own, starting with number 8, 9, 10, 11, 12, 13. So you guys are going to do those graphs, and the numbers are a lot smaller, and they're already numbered for you, I believe. Well, number 8 isn't. So number 8, I would just number, let's see what I numbered by. I numbered my x-axis by 1s from 1 to 8. And then my y-axis, I numbered by 2s. So 2, 4, 6, 8, all the way up to 16, and these are just numbered by 1s. Okay, so if you guys need help with those, if you have problems with those, let me know. But your questions that you're answering is over those last 6 problems. Okay, so hopefully you can see how putting those 2 equations on the same graph, either 3 things can happen. You can have 1 solution, 2 solutions, or no solutions. Okay. All right, guys. So hopefully that helped more than it hurt you. And if you need me, let me know. But I will talk to you soon.